So now, in my Vertex shader, I'm going to read in that normal data so that, well, I can send it to my Fragment shader, and it can do all the normal stuff with that. So, do layout location equals 2, because that's the attribute array I put it in. I can take in the vec3 normal. And I'm going to output a vec3 called normal 0, and guess what? I'm going to set normal 0 equal to normal. That's all. That's all I want to do. And in my Fragment shader, I'm just going to take in a vector3 called normal 0. So, great, now we have our now we have our normal data in our Fragment shader. Now we can do the normal part of the calculation, which is great. But what about the directional light? We don't really have a good way of sending a directional light into our Fragment shader. And that can be a little bit of an issue, so I'm going to take in, well, no, I shouldn't say that. What I'm going to do is I'm going to, well, yeah, I am going to do that. I'm going to take in a uniform. It's going to be a uniform directional light called directional light. And that's how we're going to set our directional light data. You could set this up as an array so you could have more than one directional light, but oh god, what have I done? What have I done? Directional light, okay. Now that my spelling's proper, and I'm going to move all this below our structures so it already has the data there. And yeah, I'm just going to take it in as a uniform. How's that going to work? Well, we're going to find out in a moment. Right now, I just want to go ahead and do the calculation so we can be done with it. So, right below where I add the texture color to our texture color, I'm going to add in our light. So, our light, it's going to be pretty straightforward. I'm going to first off create a vector3 called the normal. This is going to be the surface normal that we're actually going to use. And it's going to equal the normalized version of our normal 0 that we got in. Just in case it wasn't normalized when we already sent it in for some godforsaken reason. And yeah. And here, I'm just going to say total light plus equals calc directional light, if I can spell it correctly, directional light normal. There. It's going to calculate the directional light and add it to whatever ambient light's already there. Then at the end, that gives us the total amount of light at whatever pixel this is, and we just multiply that light times our fragment color. There. That's all I need to do with the shaders for now. And with that, we just need a way of sending a directional light to our shader. So the first thing I'm going to do in order to send in the uniform directional light is I'm going to sort of mirror the structures we have in our shaders. I'm going to create a new sort of wrapper class called baseLight, which is just going to contain the data for the baseLight structure in the shader. So just like that, it's going to have some vector3f color and some float intensity. Of course, except now, since this isn't GLSL, I'm going to want the private modifier so that not everyone can access this. And I'm going to create a structure. A constructor, not whatever a structure is. Public baseLight. It's going to take in some vector3f color and some float intensity. Like I said, nothing fancy here. It's just going to be a wrapper class for all the data. This dot color equals color. This dot intensity equals intensity. If I can spell it right. There we go. And I'm just going to generate getters and setters for this. So select all at the end. And there. We now have our baseLight. And just like that, I'm also going to create a structure called directional light, which is, again, going to be pretty much a wrapper class. It's going to have a baseLight, base, and the reason I'm making it have a baseLight rather than making it inherit is because I can't do that in GLSL, so I want to mirror the GLSL structure as closely as possible. So it's going to have the baseLight base and the vector3f direction. And, of course, I want the private modifier again, so private and there. Then public directional light. So yeah, just the constructor is going to take in a base light base and a vector 3f direction. And there, we now have that data. So just .base equals base. Yeah, there's really nothing fancy here at all. So yeah, I know it's not the most interesting piece of code we ever written, but hey, it's not that bad. We're almost done anyway. So there you go. We now can create base lights and directional lights, and they can have all the data there too. And yeah. So, next step is we need to access the uniforms in our falling shader. So, I'm going to add uniform directional light dot base. And that's sort of how you access all these uniforms like this. You'll say dot whatever part of it is, and then dot stuff. So just dot notation. Same thing you're probably used to. So dot base dot what? dot color. And yeah, need a little bit more than this. So dot base dot intensity. And finally dot just directional light dot direction. And there. So there you go. Now we have all the uniforms set up. But you might be wondering, how do I send in a whole directional light, like the class that I have here, directional light, as a uniform? Actually, I should close out of some of this stuff now. But the way I'm going to do this is I'm going to create my own, well, I say my own, I'm going to create new set uniform methods for specific shaders like this. So I can just do public void, well, actually just copy it from shader, so it's a little bit easier. So, see we have sort of set uniform stuff here? Yeah. I'm gonna say public void set uniform, and it's gonna take in some string, uniform name, and directional light. And the way this is gonna work, so it's not gonna be set uniform I, it's just gonna be set uniform. The way this is gonna work is I'm gonna have set at uniform. It's gonna set string, uniform name plus dot base, and it's gonna send in base light. Directional light dot get base. There. And we're gonna of course have a method for sending in base lights too. And then, other than that, set uniform f, uniform name plus dot intensity, directional light dot get. Wait, what? No, dot direction, not intensity. I don't know what I'm thinking of. Did I do that? Make that mistake here too? No. Okay. That uniform f is not applicable for. Oh, right. This vector 3f, not a direction. Not flip. I don't know. I'm getting tired at this point. Sorry. So now we can do public void set uniform. It's going to take in string uniform name, base light, and this is going to be the method for setting a base light. So set uniform name plus dot dot base dot color dot intensity. Just want to make sure I don't screw this up this time. So yeah, this is basically how I'm going to set up. This is basically how you set up structures in GLSO and send structures in Java to structures in GLSO. I guess that's what I'm trying to say here. There we go. Yeah, you get the idea. You see me doing it. So yeah, dot get intensity, and yeah. Except it's going to be set uniform F now. And finally, we are done. Well, I shouldn't say we're done, but now we're done in the sense that we have communication between. We have our communication framework between GLSL shaders and Java done. We can now send data freely, which means, even though we're not done, we can set up actually sending all this data in now. We don't need to worry about communication issues anymore. So, now that we have all of that out of the way, we can create private static vector... wait, what am I saying? Directional light. Directional light. And now we have the actual data. And I'm actually going to initialize this to something, just so, you know, we have something by default. And I should probably do that with ambient light, too. So, I'm gonna... what am I... yeah, I'm actually just gonna take whatever we have right now, and say that's what ambient light initializes to. And this way I don't get weird errors when I just immediately start using Falling Shader. I can just start, you know, doing something right off the bat. So now I'm going to create a new vector 3f, and, wait, no, new directional light, which takes in a new base light, which takes in, good god, what does it take in? 2 vector 3f's? Yeah. A new vector 3f of 111. So I'm just going to start with basic color, and what is now? Intensity, right? Yeah, I'm going to say intensity is 0. So it's not going to do too much yet. A new vector 3f000. So again, not going to do much yet. And that's going to be our basic directional light. And of course I'm going to have a method for setting that. So public static void set directional light takes in directional light, directional light. If I, come on. Good god, what does it have to be so long? And there we go. Now we can set it to whatever we want. But now we have a default, so we can start using this right away and not have the whole thing come crashing down on us. But of course, we need to set our uniform directional light to our directional light. And now, with all that finally done, we have enough in place to start using this code and seeing if what we've been doing for the past few videos, well, yeah, is actually doing anything. So I'm going to go ahead and just close out of all this. And here we go. The moment of truth. We're going to run, and we're going to get a crash, and we're going to find out what the error is. Okay. Error. Undeclared event directional light. So line 42 in our fragment shader. What happens on line 42? I misspelled directional light. That's okay. So, take 2. What happens? Hey! It actually works! Somewhat. Well, we don't really have a directional light yet, but we're doing directional light calculations, so yeah. And our default thing works too, so now I'm going to actually set a directional light to a... and I'm just going to copy it from Falling Shader, I'm too lazy. So... yeah, I'm going to copy all this. Except I'm going to change it a bit. I'm going to set our intensity to 0.8f. And direction I'm going to set to 0, 1, just 1111. And that's really all I want here. So we have direction, we have that, and oh god, I completely forgot something really important. Directional light equals direction.normalized. There. I don't want the thing going ridiculous. So now if I run, I'm not really seeing anything change. So that just means my code isn't really quite working like I want it to. Which is fine, so... and I know why, too. You know why? Because when we create our mesh, we don't generate normals, so it's not really doing anything. All our normals are 0. So I'm going to set indent true. Yes, we do want you to calculate normals. And now if I run, well, we're getting something. Not exactly what I intended, but hey. So at this point, I really do go into debug mode. And I start seeing what's gone so horribly wrong about our... actually, something is going horribly wrong. What am I even recording? I shouldn't be getting 2000 FPS when I'm recording. 1 second. Okay. I'm pretty sure I know what went wrong. First off, when I'm calculating the diffuse factor, I reverse the parameters. It's normal and negative direction. Secondly, in order for the directional light to show up in the direction I actually sent it in, I actually want to pass in the negative version of the direction, which might sound a little bit weird, but it's just so that the direction I pass in my code actually matches the direction that ends up being rendered. So yeah. And if I run now, it still doesn't work. And here's why. In my Vertex shader, my Phong Vertex, I'm just passing in the normal directly. And here's the problem with that. The vertices get transformed and moved all over the place depending on whatever happens. So in order for this to, be where the vertices actually are, I'm going to need to transform this, not by my perceived perspective transformation like this, but by the physical transformation, the translation rotation scale, not the perspective translation rotation scale. So I'm actually going to need to take in another matrix 4, one called transform perspective. Well, I should say projected. I should say transform projected, because that's more accurate. It doesn't necessarily have to be a perspective projection. And transform projected is going to be, well, just this. It's going to be this. And what I'm going to do is I'm going to take my normal. I'm going to first off cast it to a vec4. So add, should I add 1.0 or 0.0? I'll start with 1.0. Well, I'll do 0.0. It's and I'm going to multiply my transform times that. So transform times my normals. And then, since I want my normal 0 to be a vector 3 instead of a vector 4, I'm going to do something called swizzling. I love that name. Which essentially means I can get a new vector out of the vector components by just typing dot and the components I want this new vector to be made out of. So for example, this is a vector 4 with x, y, z, and w. If I just want a new vector of the x, y, and z components, I just do dot x, y, z. And it's swizzled. And I get the x, y, z components. I love swizzling. But anyways, yeah, so this should get this working a little bit more once I change my Phong shader. Now, of course, I'm going to need a new uniform. We add a new uniform for transform projected. And I'm going to say set transform projected to projected matrix. And I'm going to say set transform to world matrix. Whoops. There we go. And now, hey, it's kind of working. Not exactly working as intended, but it needs a little bit more debugging, but now you can at least see the effect. It's shining a light on it. So yeah, there you go. And I'm going to go ahead and debug this some more. Just to make sure things, well, just to make things work for you. So, one moment. And I found yet another bug. See in our generate normal methods? You don't want to use I0 for every single one of them in this calculation. You want to use the intended normal, So, yeah. If you try this, then it's working a lot better, despite that the circle thing. It appears to be coming from a single direction, which is exactly what we want, and it's shining a lot more like what we want. I think that circle thing is a bug. It actually might not be, but I'm pretty sure it is. So I'm going to keep debugging, and I'm going to see what else I can find. So, one moment. Okay, so I've tried the current code with several different meshes, and I can't get that effect on anything else. So, my best guess is that it's some bug with the mesh that I used to be using. Because, see, this triangle? Let's working on it just fine. You get full lighting effect, full everything, working exactly as intended. So, I don't know. I think somehow I screwed up that mesh whenever I created it way back when, so I'm just going to move on to this new triangle mesh, since this one isn't bugged. As for my frame rate suddenly not being affected by my camcorder, I'm stumped. I don't know. I guess now that I have lighting, my camcorder's cool with my engine now, so I don't know. I don't know why I'm getting normal frame rates now, but there you go. So, yeah. Now we've got diffuse lighting up. It's working on our object perfectly fine. Again, I don't really know what that weird circle thingamajiggy was, but hey. It works fine on every other mesh I tested it with, so there you go. Hope you enjoyed, hope you learned, and I'll see you next time.